Hello students, welcome. Today we want to do KCSE 2025 chemistry predictions. The code for chemistry is 233. We want to do chemistry paper 2 with the code 233/2. Remember, chemistry paper 2 is a theory paper and it takes 2 hours for it to be done. So now let's proceed to the instructions given. These are the instructions. Kindly have a look at them. Then we are going to proceed to the table. So the way we have said, chemistry paper 2 can have 6 questions or 7 questions. For our example here, it is having 7 questions. So in this lesson, we are going to do question number 1, which will be from the periodic table. Kindly stay with us until the end of the video. So in question 1, we are told the grid below represents part of the periodic table. Study it and answer the questions that follow. And next we are told letters are not the actual symbols of the elements. So this is the grid that we have been given. So Roman 1, we are told select a letter that represents the most reactive nonmetals. So we are supposed to explain. So learners, when we are asked the most reactive nonmetal, we are going to check it from the halogens. So what are halogens? Halogens are group 7 elements of the periodic table. So this is group 1, group 2, group 3, group 4, group 5, group 6, group 7. This is group 8. So this side is group 7. This is the group that we are talking about. The next, what have we said? Because we are having 2 letters here, S and Y. What have we said about the reactivity of halogens? We see it decreases down the group. That means S is more reactive than Y. So the answer, first of all, is S. The letter is S. So let's explain, because we are told explain or give a reason. So 1, we can say it has the highest tendency to accept or to gain electron. That's the first reason. Then number 2, we can say the reason as we can say it is the most electronegative. That's the other reason that we can give out. Then Roman 2. We are told select a letter that represents an element that forms an ion with a charge of 2-. So we are supposed to look for an element. 2- means it gains 2 electrons. So that means these ones are halogens. The way we have said, they are going to gain 1 electron. So that means this group 6, they are going to gain 2 electrons. So the element that we are talking about there is X. We can prove, for example, what is the atomic number of X? So we can know by just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we're having 16, the electronic configuration will be 2, 8, 6. So for it to become stable, it gains 2 electrons or loses 6 electrons. So that means gaining 2 electrons is better because it requires less energy than gaining 6. So that means this element X gains 2 electrons rather than losing. So when we gain electron, we will be given a negative sign because the number of electrons are more than the number of protons. So the answer is X. We are told only select the letter. So next, Roman 3. We are told select an alkaline earth metal. So what are alkaline earth metal? These are group 2 elements of the periodic table. So when we check, this is group 1, this is group 2. So we have only 1 letter there, and that is letter M. So those are our answers in the first 3 parts. If they could have asked us the alkali metals, we could have said Z. If they could have asked about the noble gases, we are having letter B. If halogens, we are having S and Y. So let's check the answers for the first 3 before we proceed to Roman 4. So these are the answers for the first 3 parts of question number 1. The Roman 1, we are told select a letter that represents the most reactive nonmetal. So we said it is S, and the reason is it has the highest tendency to gain or to accept electrons. Or you can say it is the most electronegative. That's what we can say. So tomorrow you can be asked about the most reactive metal. If you are told the most reactive metal, we look from the alkali metals. So in our case, we have only one alkali metal, which is Z. In case we have more than one letter there, like we are having here maybe A, we will use the trend in the reactivity of alkali metals, and we said reactivity of alkali metals increases down the group. So that means we are going to select Z because Z is more reactive than A. So Roman 2, we are told select a letter that represents an element that forms an ion with a charge of 2 minus. The way we have said, it is X, and we have explained that. Then Roman 3, select an alkaline earth metal, and we said that is N. We are going to proceed to Roman 4. Let's proceed to Roman 4. We are told identify the least reactive element. Learners, when we are asked about the least reactive element, we check from the noble gases, because noble gases, we said, they neither gain nor lose electrons. In other words, they are stable. So that means they are unreactive. So we check the letter that is in the noble gases. So check, we're having letter B. So that will be letter B. Then Roman 5, we are told what is the formula of the compound formed when M reacts with B. So what is M, then what is B? That's what we are going to start with. So when we check M is calcium first of all. That's M is calcium, you can check. Then B is carbon. So when calcium reacts with carbon, what we are going to get is calcium carbide. And how do we write calcium carbide? Calcium carbide is written like this, CaC2. That's how it's written, calcium carbide. So here we are having M for the side of calcium, so we are writing M. Then we are having P for the side of carbon, so we are going to write the 2. So the answer that we are supposed to write is MB2 like that. So here you are not supposed to say we write M, then we write B. The valency for M is 2, the valency for P is 4. So we interchange the valency. That's not what we are supposed to do. Because when we do like this, the problem that we are going to have here, we are going to get M2B1. And this is calcium carbide. We are supposed to write CaC2. Remember, calcium carbide, we have learned it when we are preparing a line gas in the lab. We will take calcium carbide, then we will use to add water so that we get calcium hydroxide and also ethylene gas. So the formula is supposed to be MP2, not M2P. You have to know that. So next, Roman 6, we are told what type of chemical bond exists in a compound formed when R and S react. So what is R and what is S? Let's check. So here R is nitrogen, then S is here, it is fluorine. So that means both nitrogen and fluorine are nonmetals. So the type of bond that we are going to have there will be covalent bond, because we said covalent bond exists when nonmetals react. So now let's check the answers for those before we proceed to Roman 7. So we are in Roman 4. We are told identify the least reactive element, and we have picked the B because B was in the side of the noble gases. Remember, we said they are inert, or they are non-reactive, or they neither gain nor lose electrons. For that reason, they will be the least reactive. Roman 5. We are told what is the formula of the compound formed when M, which was calcium, reacts with B, which was carbon. So we're going to have calcium carbide, so we write MP2. Then Roman 6, we are told what type of chemical bond exists in a compound formed when R and S react. So we said R is nitrogen, then S is fluorine. So both nitrogen and fluorine are nonmetals. So when nonmetals react, they form covalent bond. So now let's proceed to Roman 7. We are told write the electronic configuration of element V. So let's check element V. So element V is here. We can do two ways. The first way, we know the atomic number of V, so that we write the electronic configuration. So we're having here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it has an atomic number of 13. So the electronic configuration will be 2, 8, 3. The second way that we can get is that we check the energy levels. So V is here. This is the first energy level. The first energy level carries a maximum of 2 electrons. So next is the second energy level. It is here. So it takes a maximum of 8 electrons. The third energy level is here. So it is inside the third energy level. So 1, 2, 3. So we're going to write 3. So it has an electronic configuration of 2, 8, 3. That was aluminum. So Roman 8, that's the last one. We are to compare the atomic and ionic radius of element Y. Then we are to explain. So let's check element Y first of all. So element Y is here. It is a halogen. And when we check, this is chlorine. We have fluorine, chlorine. So what have we said about the combination of the atomic and ionic radii of halogens? We say the ionic radii is bigger than the atomic radii of halogens. So reason was this is due to the gain of that 1 electron. Let's check the answer. So we are going to start with, first of all, Roman 7. We are to write the electronic configuration of V, and we said it is 283. Then let's do combination. We are saying ionic radius is larger or bigger than the atomic radius of element Y. Reason, this is due to the gain of 1 electron. Hence, reduces the effective nuclear attraction, causing the electron cloud to expand. That is the reason why the ionic radius is bigger than the atomic radius of element Y. Learners, that is the end of our class for today. Thank you for watching.